All right, guys, in this video, we're going to go over kind of the first part talking about what a complex number is, talk a little bit about what an imaginary number is and how we use that to help us make complex numbers. And then we'll finish by talking a little bit about adding and subtracting complex numbers. All right, so in the world of numbers that you guys started learning about in elementary school and grade school, and then moving into your high school experience, you've dealt with only real numbers at this point. So we are going to talk about what an imaginary number is, which comes down to using something called the letter I. All right. So this all came from this idea, this question of if you had x squared equal to a -1, so I'll write that here, and you wanted to get x by itself, you would take the square root of both sides. And so what happens is you end up getting the square root of a negative number. All right, and up to this point, you've been told and you know that you cannot actually get a value from that. There's no way to square a number and get a negative, right? When you square a number, no matter what it was, it's going to be a positive. So mathematicians decided to allow them to continue working. They needed to come up with a way to deal with this. So they decided to use the letter I to represent this, all right? So we'll talk a little bit about that plus or minus later. But the idea is that you would have plus or minus I would be answer for this, all right? So I is the square root of -1, okay? Now, when you see this happen inside radicals, like these 4 examples here, all right, what you should do is treat it as if you had that -1 separate from your positive number, all right? So essentially, I break this down into 2 different square roots where the square root of -1 is separate. We know that's I. And then the square root of 5 cannot be reduced, so we just leave it like that. Okay? Now with B, right, if I separate it just like I did before, I get -1 in that radical times 49. Now we do know what the square root of 49 is. That is 7. And if you end up having any values come out of the radical, you're going to write them in front of the imaginary piece I. All right, so we would write 7I for part B. Part C, we break this down again into that negative, and then I'm going to, or -1, excuse me, then I'm going to break this down into 9 times 2, right? You could use 6 and 3 if you wanted to, but I use 9 and 2 because 9 is a perfect square. We know this is I, the square root of 9 is 3, and the square root of 2, nothing can break down from that. So I would write this as 3I times the square root of 2. And our last one here, again, lots of options to break this down. So we have the square root of -1 times the square root of 16 times the square root of 3, because that 16 is a perfect square. So this is I, this is 4, and this is the square root of 3. So putting it all together, you get 4I times the square root of 3. All right, so that's how we're going to treat that. Now, finally, before we get into actually the addition and subtraction with these complex numbers, let's introduce what it is. So A is always going to be your real component of your complex numbers, and BI is going to be your imaginary component. So when you hear me talk about complex numbers, there's going to be a real piece and an imaginary piece. And that imaginary piece, as you notice, is going to include that letter I. Now, if you have A equals 0, right? So if your real component is 0, right? If you had 0 plus 6I, you're not going to write that. You're just going to write it as 6I. All right. If B equals 0, so if your imaginary component is 0, and you had 7 minus, 7 minus 0I, you're not going to write that. You're just going to write 7. Okay. Now, sometimes that happens, and then you don't have a complex number. All right, so let's skip this page, all right? And in class, I'll go over some kind of fun stuff here with taking I and raising it to certain powers. So we'll do that in class. It's like a little bit of a challenge. Let's talk about adding and subtracting. Now, this will feel fairly straightforward just because when you add or subtract complex numbers, literally all you're doing is adding or subtracting the like terms, right? So your work in middle school with combining like terms is going to serve you well here. All right, so when it's addition, I just copy this down because if you distribute the +1 onto the 7, that's going to be 7, and multiplying 1 times -6i is going to still be -6i. So I'm going to go ahead and take the 5 and the 7 and add those together to get 12. And then I'll go ahead and take the 3i and the negative 6i, put those together and get minus 3i. All right, so this is going to be our answer. You can see the real piece and then the imaginary piece. Now, when I have subtraction, I am going to go ahead and distribute that negative. The opposite of negative 4 is positive 4. The opposite of 3i is negative 3i. Again, combining like terms, negative 7 and 4 is negative 3. And negative 2i and a negative 3i is negative 5i. Okay, let's go to the next one. All right, I've got a subtraction here. So the opposite of negative 2i is plus 2i. The opposite of 9i is minus 9i. Distributing a positive, I'm just going to copy those down without the parentheses. All right, so I have 6 and negative 8 to give me negative 2. Now this time I do have 3 different imaginary pieces. I've got all 3 of these. Make sure you're looking at the signs. So 2i and a negative 9i is negative 7i. Negative 7i plus 4i is going to be negative 3i. All right, let's do the next one. Distributing that subtraction again to get minus 3 minus I, and then bring down the one after the addition. So let's see, I have negative 3 and a positive 2 is going to be negative 1. 2i minus I is going to be 1i. 1i minus 3i is going to be negative 2i. All right, 2 more to go. All right, again, when you have addition, I don't need those parentheses. I am going to distribute the negative and get plus 12 minus 11i. Bring down the 6i. 9 plus 8 is 17. 17 plus 12 is going to be 29. Negative 3i and negative 11i is negative 14i. Negative 14i and 6i is negative 8i. And last one here. Take off the parentheses. Distribute this negative. And let's combine like terms. 2 plus 10 is 12. 12 minus 8 is 4. 5i minus 7i is negative 2i. All right, so that's it for adding and subtracting. That's part 1. When we do part 2, we'll do multiplying and dividing. Come see me if you have any questions.